So imagine looking on the horizon and sunrise is half.
NASA has released footage of a never-before-seen event in which the asteroid known as Betelgeuse exploded overhead, obliterating a large portion of its surface. The event, known as a supermassive ejection, is 400 billion times the size of an ordinary solar system. According to the space agency, scientists call this event the observation period of stellar evolution. The fact that a star can leave such an object makes many people curious. The cataclysmic explosion of this red supergiant turned our understanding of the universe upside down. Why did Betelgeuse explode? How will this affect the universe? The constellation consists of many stars arranged according to myths and legends, and they are still used for navigation today. One such star is Betelgeuse, one of the biggest and brightest stars of the night, a bright purple star called Betelgeuse in the upper right corner of Winter Orion's guardian. But upon closer examination, astronomers found that it was a ghost with a continuously beating heartbeat for up to 400 days. Betelgeuse is easy to identify due to its bright yellow-red color. It is good to suspect that stars have different colors. Also known as Alpha Orionis, this star is the second brightest star in the constellation after the blue supergiant Rigel. Due to its versatility and unusual name, Betelgeuse is an interesting object for research and observation. The star, often called Alpha, is the brightest star in its constellation. Although Orion's brightest star, Rigel, is brighter, Betelgeuse is referred to as Alpha Orionis because of its brightness, size, and red color. He is also one of the most famous stars. It is worth noting that the star was a model for the characters in the movie Beetlejuice. Betelgeuse is the 7th brightest star and the 10th brightest star in the sky, visible from most of North America, Europe, and Canada. The world is also close to Betelgeuse. Betelgeuse is the brightest star in our galaxy and the closest star to Earth. Only 200 red supergiants have been detected. The radius of the Sun is approximately 764 times that of Betelgeuse. If this star replaces the Sun in our solar system, it will reach beyond the asteroid belt and even Jupiter. This suggests that Earth, Mars, Venus, and Mercury will be completely absorbed. Betelgeuse is 16 times larger than the Sun. This supergiant star has a solar luminosity of 126,000 and can be seen from 548 light-years away. The temperature of the star is 3,600 Kelvin, which is colder than the Sun. Only 133% of Betelgeuse's radiated energy is visible light. If the human eye could see all wavelengths of light, Betelgeuse would replace Sirius as the brightest star in our night sky. Betelgeuse crashes into a large solar system every 10,000 years. Red stars are surrounded by nebulae because these objects are unevenly removed from the star in all directions. Betelgeuse is surrounded by a cloud of objects 250 times larger than stars. This is the distance between the Sun and Neptune, the farthest planet in the solar system. Our solar system periodically shoots matter into space called solar flares. However, the Sun gives off only a small portion of its outer atmosphere, so this event is called a coronal mass ejection. Therefore, coronal mass ejections and surface mass ejections will occur at different times. When a star expels some of its unstable atmosphere, it causes a coronal mass ejection. Coronal mass ejections from the solar system occur frequently and can affect Earth and its inhabitants. Coronal mass ejections move at speeds in excess of 1,800 meters per second, launching magnetic fields and plasma into space, sometimes reaching Earth within an hour. When a large coronal ejection occurs on the side of the Sun facing Earth, it can impact and damage Earth's satellites and power grids, sometimes causing risks to people on Earth. Recent discoveries revealed a specific reason why Betelgeuse went dark in 2019. Additionally, Betelgeuse's famously steady draw has also changed. According to NASA's press release, Betelgeuse's coronal mass ejection is unique because it released 400 billion times the magnitude of a typical coronal mass ejection, causing the star to shake like a sheet of gelatin. The star's convection cell may face a problem as the photosphere, which we think of as the star's surface, tries to rebuild it, personally said astronomer Andrea Dury of the Center for Astrophysics. Astronomers have been tracking the star shape continuously for the last 200 years, but it is no longer there. All red giant stars, including Betelgeuse, are dying, and being able to observe this process will allow scientists to learn more about the evolution of stars. Most stars on Earth are powered by nuclear fusion, which eventually fizzles out, causing the star to undergo an interesting series of stellar changes before eventually dying. When a star is born, it consists of hydrogen that comes together under the influence of gravity in the star's core to form helium in a nuclear explosion. Most of the heat and light energy is usually released during the fusion process. This energy goes to the surface of the star and is released into space as photons. As the star ages and its main fuel hydrogen runs out, helium begins to combine with carbon to form carbon. When helium is used, neon eventually combines with carbon to form a metal. When this happens, the fusion of neon and iron absorbs more energy than it releases. Because nothing can resist the star's gravity as the iron begins to melt, the star collapses in on itself, causing the supernova explosion. Supernovae are the most powerful in nature and produce more than 10 billion suns. Stars change color from the youngest hottest blue to the oldest cooler red, depending on the stage of stellar evolution they are experiencing. While the Greek scientist Thales 345 BC 250 BC curiously named Betelgeuse's red color 3 centuries earlier, Chinese astronomers had described the star as yellow, indicating that Betelgeuse had previously been a yellow supergiant star. Larger stars generally burn their hydrogen faster and die quicker. Although Betelgeuse is only 10 million years old, he is definitely nearing the end of his life. Our Sun is approximately 5 billion years old and is still in its brightest period. Also, since Betelgeuse is nearing the end of his life, a supernova will occur soon. Betelgeuse goes through 2 cycles of darkness and light. The second cycle occurs approximately every 5 years and lasts approximately 100 days. The star's outer shell is expected to expand and contract during this cycle, changing the star's orbit and average temperature at each step of the cycle. Astronomers will better understand how red stars lose size in their final days before exploding into bright supernovae. As Dupree noted of Betelgeuse's explosion, we've never seen a large amount of material eject from a star before. We didn't know what was going to happen. This is a new phenomenon that we can observe using Hubble to resolve surface elements directly. We observe the evolution of stars in real time. However, due to the strange phenomenon, it is not clear whether this development indicates the Betelgeuse supernova explosion. Despite its long cosmic lifespan, Betelgeuse is still not at the end of its life. NASA has warned red supergiants are dying fast, and Betelgeuse will explode within the next 100,000 years. According to NASA, it has been the focus of intense research since the 1st century. Recently, a scientist named Serafina Nance and her team tried to determine the likely time when a red supergiant star like Betelgeuse would explode as a supernova. Nance and his team conducted several experiments using Betelgeuse as a model to understand how massive the star would be. They then compared their findings to field observations. Why is Betelgeuse shrinking and becoming out of sync with his normal cycle when it seems like he won't explode for another 100,000 years? Betelgeuse was ejected from its home in the constellation Orion OB1, a star cluster in Orion's belt, and appears to be traveling 4 light-years through the interstellar medium at 30 km per second. Fast-moving stars create shock waves. Since its decline in October 2019, Betelgeuse's brightness nearly tripled from 0.5 magnitude to 1.7 magnitude by mid-February 2020. In the past 10 days, the stars started to shine again. However, Betelgeuse's darkening seems to stop completely after 5 days, completing the darkness. Given the lack of significant changes in infrared on February 24, 2020, it appears that the recent lack of visibility does not reflect the needs of young people. Another study that day concluded that the star's dimming was mostly due to dust. The fading seems to indicate that the second dimming event will occur sooner than expected. Astronomers announced the discovery of a second cloud from Betelgeuse in conjunction with the last major dimming of the star's light on August 30, 2020. In June 2020, it was suggested that cold areas in the photosphere may be responsible for the dust, and in August, a second study confirmed the first hypothesis. The dust is thought to originate from gas escaping from the star. Removing large amounts of soil oil can create dust. According to a 2022 study using the Hubble Space Telescope, this material is ejected millions of kilometers from the star's surface, where it cools and compresses into faint stardust. The fragmented photosphere, which was about several times the weight of the Moon, cooled as it entered space and formed a cloud that covered the star from the perspective of an observer on Earth. This fading started in late 2019 and lasted for several months and was clearly visible even to observers. After observing changes in the star's brightness, more importantly, the supergiant's 400-day pulse rate has disappeared. Since nearly 200 years ago, astronomers have been tracking this cycle by analyzing changes in Betelgeuse's motion and brightness. His reaction revealed the explosion. Astronomers have now developed a theory that could explain this effect. The star is slowly but surely rebuilding its energy, and its photosphere is also being rebuilt. The star's orbit is always disturbed, and its interior vibrates like a struck cymbal. Large-scale stellar surface mass ejections have never been seen before. There are still things we don't fully understand. We can directly observe this new phenomenon and use Hubble to see surface features, observe the evolution of stars over time. When it will be, maybe not in our lifetime, but the truth is that no one really knows. It could happen tomorrow, it could happen in 1,000,000 years. Will the world be destroyed by the Betelgeuse supernova? No, Betelgeuse's explosion will not affect or partially end life on Earth because it happened so far away. Astronomers estimate that for a supernova to be dangerous to humans, we would have to be 50 light-years away from it. Plus, Betelgeuse is way more than 10 times bigger. Instead, everyone in the world will see the beauty of the star shining at night at the same time. Finally, because Betelgeuse is nearby, astronomers will be able to study the star as it undergoes a supernova explosion. Betelgeuse is no longer visible at night, so don't look for him there. Even if it goes supernova now, we won't see much unless it's in mid-August. Betelgeuse may have gone supernova 529 years ago, but we still haven't seen its light. Scientists are excited about the chance to see Betelgeuse's collapse and recovery. Meanwhile, as Hubble continues to study the star, NASA's James Webb Space Telescope can track the Betelgeuse object as it travels through space. Thanks you for watching, and don't forget to click on the video on your screen to see more exciting videos about space science and new discoveries.